Okay, welcome to section 2.1.5. We're going to be talking about arithmetic sequences. Remember, arithmetic sequences. They are our linear sequences. They're adding the same thing each time. Geometric are exponential. We're multiplying by the same thing each time. So for problem number 1, we're going from 9 to -5 to -1 to 3 to 7. What we're doing is we're adding 4 each time, making it arithmetic. We're adding 4 each time. Now the initial value, I like making a table for this, N and T of N. That's the notation we're going to be using for these sequences. Now, term 0, 1, 2, 3, 4, we're not given term 0. That -9 is term 1. Now, to go backwards, since we're adding 4, we have to subtract 4. We're at -13. What are the initial value and the generator for each sequence? Now, the initial is -13, and the generator, our slope for this, is 4. Now that difference is the generator. So what we're going to do is we're going to skip to problem D, and we're going to write a rule. So our rule, T of N, equals our slope, because it's going to be in that y equals mx plus b form. Our slope is 4, so it's going to be 4n minus 13. That's our rule. We're going to graph this. I'm going to go by 2's here just to make sure it fits. So we're going to be at 0, -13. Then we're going to be at -9, -5. That's not right. Excuse me. Then we're going to be at -5. Then we're going to be at -1. And then we're going to be at 3. So there's our graph. Now it is linear, but we're going to graph it as discrete. Sequences are going to be discrete. Okay? And that common difference, that's our slope, our rate of change. That's our generator. Let's go to the next page. We have -4 to -1 to 2 to 5. So you can look, we're adding 3 each time. I'm going to make a table, N and T of N. Remember, our table, we started term 0, 1, 2, 3, 4. Now, the given first part there, that's term 1. So term 1 is -4, -1, 2, and 5. We're adding 3, so to go backwards, we're subtracting 3, we're at -7. So our slope is 3, and our y-intercept, our value for b is -7. So this is arithmetic, it's linear. So think y equals mx plus b. For our notation, we're going to use T of n equals 3n minus 7. That's our rule. Is it possible for T of n to equal 42? So what we're going to do is we're going to find out, are we going to get a whole number for n? Since this is discrete, our n value has to be a nice whole number. So 42 equals 3n minus 7. So you can add 7 to both sides. 49 equals 3n, divide by 3. N equals 49 thirds. It doesn't divide evenly, so not possible. 42 would not be one of our outputs for this. And that's because it's a discrete sequence. It's discrete. We can only have whole number values. Now for a function, functions are continuous. So it is possible. And since it's continuous, we don't just have the values, but we have all the values in between those dots. So once again, for sequences, they're discrete. Functions are going to be continuous. So function, continuous. That domain is all real numbers. X can be any real number. But for T of n, our sequence, it's discrete. The domain is only integers. Our values for n have to be an integer. And an integer is a positive and negative whole number, including 0. All right. Now, we're moving into some more difficult problems. Not difficult, we just have to bring it from new way to write it into an old way to write it. So Trixie wants to create an especially tricky arithmetic sequence. He wants the 4th term to equal 11 and the 49th term to equal 371. That means that T of 4 equals 11 and T of 49 equals 371. Is it possible to create an arithmetic sequence? Yeah. So remember that number inside is our input, our x, and the number on the outside is like our y, our output. So we have the inputs and outputs. So thinking about it in a more familiar form, we have the point 411 and 49, 371. So between those 2 points, we can find the slope. y2 minus y1, x2 minus x1. 371 minus 11 over 49 minus 4. So it's going to be 360 divided by 45, which is 8. So our slope is 8. Now we need to find our y-intercept, our starting point. Remember, arithmetic sequences are linear. Y equals mx plus b. So I can pick either one of the points. I'm going to use 411 because I feel like it. 11 equals 8 times 4 plus b. 11 equals 32 plus b. Subtract 32 from both sides. b equals 21. So it's telling us that T of 0 equals 21. That's our initial point. So using that, we're going to write our sequence. Instead of writing y equals mx plus b, T of n equals m, which is 8, n plus 21. There is our rule for that sequence. Now, the common difference is negative 17 for the next one. That's our slope. And T of 15 equals 93. So what that's telling us is that 15, 93, that's one of our points. We need to just find the y-intercept. Now, I don't have to make a table or anything like that. I can use y equals mx plus b. The common difference is our slope. This first point is x, the second point is y. So it's going to be 93 equals negative 17 times 15 plus b. 93 equals negative 255 plus b. Add 255 to both sides. So we get B equals 348. So T of n equals our slope, negative 17n plus 348. I'm going to split this into two videos. I'm going to do another one with more practice problems, and I'll see you in the next part.